this demo, I'll walk you through how to build and run an interactive data dashboard using Streamlit, all directly in the cloud with repl.it. We'll be using Python, Streamlit, and a few essential data science libraries to create a clean, user-friendly app for exploratory data analysis. Whether you're uploading a CSV file or connecting to a public data set, this dashboard lets you filter, visualize, and profile your data with just a few clicks. So here I am in repl.it. I am using the paid version so that I can have private repositories. I'm going to go ahead and create an app. I use the Python template, give the app a title. We're going to call it Data Analysis Streamlit App. I want it to be private. This spins up the Python environment where I can create my app. There we go. I'm going to click over here to open all the files in the app. I'm going to create a new file. I'm going to call this requirements.txt. I'm going to list all the Python packages that I'm going to need to develop the app. And then I'll install those packages by pip installing from this file. Here are all the packages. Got Streamlit to build the app interface, pandas for data manipulation, matplotlib for plotting, Altair for interactive charts, and wide data profiling for generating data profiling reports. I can see all the available tools over here. I'm going to click on Shell, and I'm going to pip install from the requirements file. I'll run that. That should install all those Python packages. It's installing everything into my repl.it environment. I'm going to go to my main Python file that the repl.it app provided for me. I'm going to rename this to EDA Streamlit App. I'm going to build my Streamlit app right in this file. Let me first add my imports. First, I'll import Streamlit using an alias of st, pandas, matplotlib, Altair, wide data profiling, and then the Streamlit components for embedding HTML reports. Here I'm setting up the page configuration for my Streamlit app. Set page config function lets me customize the browser tab title and overall layout, and then I'm going to use st.title to display the main title of the app, Exploratory Data Analysis App. Here I'm creating a sidebar element to let the user choose how they want to load their data. First I add a header, data source, and then radio buttons with two options: uploading a CSV file directly or entering the URL of a public data set. Here I'm just adding a placeholder for the loaded data frame. Ultimately, I'm going to load my data and put it into a data frame in this variable. This handles the first data input option. If the user selects Upload CSV, it creates a file uploader for uploading that file, and then using pandas reads the file into a data frame stored in DF. This block handles loading a data set from a public URL. If the user chooses Enter Public URL, a text input box appears in the sidebar. When a URL is entered, pandas will read the file into the data frame DF. If it's successful, it'll present a success message, otherwise an error message. This next block runs only if the data is loaded. First, it shows a preview of the data set by calling the head function on the data frame. That shows the first 5 rows. Then it shows some basic data properties. It creates a subheader. Then it shows the shape of the data frame. This is high-level information about the rows and columns. And then some information about any missing values in the dataset. This section adds an interactive filter to the sidebar. First, we create a header. Then we create a select box, which allows the user to select a column to filter on. Then we get all the unique values for that column. And then we display those unique values in a multi-select box. This allows the user to choose which values to include in the filtered data. Here we actually filter the data using the selected values, and we store that in filtered DF, and then we display it in the app. In this section, we're going to allow users to create simple visualizations of the data. So here I just create a subheader and then a select box, which gives the user 3 options, 3 different types of visualizations: histogram, box plot, and scatter plot. So in this section, I'm generating a histogram to help visualize the distribution of values in a numeric column. First, I check to see if the user selected histogram, and if so, I create a select box with all of the numeric columns in the dataset. Based on the user's selection, I use Streamlit's bar chart function to quickly plot the values. It gives a basic high-level view of the data's distribution. If the user selects box plot as their chart type, this section lets them choose one column for the x-axis, typically a category, and one numeric column for the y-axis. Then using Altair, it generates a box plot that shows the distribution, median, and outliers for each category. Here I'm specifying the nominal or categorical column of data for the x-axis, and here it's the quantitative or numeric column of data for the y-axis. And here we actually display the interactive chart and scale it to fit the app layout. This section creates a scatter plot when the user selects the chart type. It prompts them to choose two numeric columns, one for the x-axis and one for the y-axis. Then it uses the scatter chart function to plot the data points. Scatter plots are useful for spotting relationships or correlations between two variables. This section generates a full data profiling report using the Y-Data Profiling library. It creates an in-depth summary of the data set. And then we render the report directly in the app so users can explore it without leaving the dashboard. This part of the app allows users to download the filtered data as a CSV file. First, we convert the data frame to a CSV string, and then we provide a Streamlit download button to download that data as a file in the CSV format. Finally, if no data has been loaded yet, we display a friendly message. Next, we're going to tell Streamlit to run the app file. I'll do this in the shell. Here's my command. Specify the file and the port. Also disable cross-origin resource sharing restrictions. This is sometimes needed in repl.it. You can see once it starts running, it does ask for an optional email address. I'll just keep going. Looks like it's loading. And here's the app running in preview mode. I'm going to click New Tab to open the app in its own tab in my browser. There's the app. To test this, I'm going to start with a CSV file. I can upload it here on the left. First, let me show you the CSV file that I want to upload. Here it is. This is a simple data set with names, ages, genders, incomes, and departments. Each row is a different person. We're going to load this into the Streamlit data dashboard and do some basic exploratory data analysis. So let's go back to our app. We're going to upload that CSV file. On the left side, I'm going to click Browse Files, then upload the file. There it is. You can see the preview of the dataset here right at the beginning. First 5 rows of data. Here we can see the missing value information for the dataset. You can see all the columns listed, and you can see there are no missing values. On the left, you can see we have the ability to filter the data. We can filter by column, and then I can filter by values within that column. Here I'm going to filter by column name. I can see a preview of the filtered data on the right. So now I'm going to remove some of the values in the name column. And you can see the presentation of the data on the right is updated in real time. If we move down to our visualization section, you can see I can choose a chart type. It displays a histogram by default, and I can select a numeric column, and it displays a histogram for that data in that column. I'm going to go ahead and select scatter plot. The idea here is to visualize the relationship between two variables. Here I can select a numeric column for the y-axis and the x-axis. They should compare income to age, but this visualization does not look right. I don't even know how to read this. So let me take a look at the code that generates this scatter plot. Here's the section that generates the scatter plot. There's definitely something wrong with this code. I need to make some updates. I'm going to replace all this code here. Creating the data for the x-axis and y-axis is the same, but here I'm going to use Altair's charting library to actually create the scatter plot. It's a lot more customizable than Streamlit's built-in chart API. Let me go back here, try to refresh my application. Oh, I may need to rerun Streamlit. I'm going to go to the shell. Let's rerun the app using Streamlit. There we go. Skip this. I'm just going to open this in a new tab. Let me re-upload my CSV on the left. There we go. I'm going to scroll down to the visualizations. Histogram by default. Let me switch this to income. I'll come back to the histogram later. Let me select scatterplot. For the y-axis, income. So this compares age to income. This looks correct to me. Now each dot represents a person, displaying their age and their income. Let me just switch the axes. Income for the x, age for the y. Similar representation. Now let me select box plot. This should show the numerical distribution for a single categorical variable. This should show age distribution for the name variable. I'm not quite sure if I have the right data for this box plot, but let me check my code. Here's the section that generates the box plot. I'm actually going to replace this code. It's almost the same. Filters all the numeric columns, filters the categorical columns, confirms we have both types of columns, otherwise displays a warning. The user selects a categorical column and a numeric column. Then we use Altair to create the box plot. Set the categorical column, set the numeric column, tooltip, make it interactive, and then we display the box plot. Now let me go back to the app, upload my data, scroll down to the visualizations, check the box plot. We change the x-axis to gender. There we go. Now we can see the age distribution per gender. Let me change this to department. Now we see age distribution per department. We change y-axis to income. This is income distribution per department. Boxplot seems to be working as designed. Let me just confirm the histogram. This should show the distribution of age, meaning the number of people with each given age. I'm not sure that's right. Let me check my code. The current code provides a fast and simplified overview, but it's not a true histogram with bins. For more control, I'm going to use Altair to customize bin sizes and the layout. Paste in the new code here, allow the user to select a numeric column, and here's where I actually create the histogram using Altair. You can see I customized the bin size. This should create a nicer and more accurate histogram. I'll go back to my app, open up the tab, load my data, scroll down to visualizations. There's the histogram. Much better. This shows the number of people with each given age. And this shows the number of people with each given income. The frequency is on the y-axis. Now let's scroll down to the data profiling report portion of the dashboard. This performs a lot of basic analysis on our data. You could see a lot of additional information about the data in every column. You could change the column here. You could view interactions between different numerical variables in the data. You can see it creates a scatter plot by default. This is income as it relates to age. You can view information about possible correlations in the dataset. It shows a heat map by default. You can also see this in table form. Additional information about missing values in the dataset. You can see a count here for each column. You can also see it in matrix form. A sample of the data, the first rows, the last rows. And finally, we have an option to download the filtered data as a CSV. So let me filter my data. I'm going to filter out some of these names from the data set. Let the dashboard update. We go ahead and download the filtered data. And this provides me with a new CSV file. And here it is, the filtered data. I only have 4 people. Now I want to show you how to load data from a public URL. I'll change this option here. I'll enter the URL in the text field. This is a publicly accessible Titanic dataset. You can see all my columns here. Here are all the unique ages of the passengers on the Titanic. Let me look at the survived column. It's either going to be a 0 or 1. I'm going to filter out the zeros. I only want to see those passengers who survived. You can see my filtered data on the right. For my visualizations, let me view a histogram by age. So the number of passengers with each age. A box plot might be interesting. Here's the age distribution by gender. Let's look at a scatter plot. We can look at age as it compares with fair. Now let's look at some data profiling. I can see a profile of every column. I can view the interactions between different variables, the correlations between different variables, missing values. Here's our sample of data. And then I want to go ahead and download the filtered data, which is information about survivors only. And here it is. Here's my CSV file. Only the records with a 1 in the survived column are in the file.